Okay, this is for Year 12 method. It comes out of exercise 4.7 and it's using data to find models, particularly using the calculator. I'm going to look at example question number 4 and question number 9. Question number 4 is drawn there. The data to the right is best modelled by the function y equals e to the ax. Find the value of a. And I've been given a scatter plot. Not a great scatter plot, because for me to be able to get a reasonable value for a, I've got to read that scatter plot and get accurate readings. Now if I look at this point here, when x equals 1, y is a little bit more than 1, but how much more is it? Is it 1.1? Is it 1.2? If we look at x equals 2, is that exactly y equals 2? No, it looks a little bit below. Is it 1.9? Is it 1.8? Is it 1.85? It's very difficult on a scale that hasn't really been accurately identified, and then I've got this big dot. Do I look in the middle of the dot? So you can see that there's a fair range of interpretation and scale error that's going to happen in this question. Do I take one of the points? Do I take two? Do I take three? There's only one unknown, A. If I just take one of the points, is that as accurate as taking all the points? So since they've given me 7 points, I'm actually going to use 7 points. I'm going to read it as close as I can to one decimal place. So statistics, 1, enter 2, enter 3, enter 4, 5, 6, 7. So there's my 7 points. When x equals 1, y looks as if it's above 1, so I'm going to say 1.1. When x equals 2, it's a little bit below 2, I'm going to say 1.9. When x equals 3, y seems to equal maybe 2.2. When x equals 4, y seems to equal a little bit above 3, I'm going to say 3.1. When x equals 5, y equals a little bit above 4, I'm going to say 4.1. When x equals 6, it's well above 5, it's around about, I think about 5.3. And when x equals 7, it's 7, a little bit above 7, or is it above 7? Oh, it's so hard to tell, isn't it? I'm going to say 7.1. So, there is my estimates for the y values based on that graph. You might have slightly different values, and of course, your value for a is going to be slightly different accordingly. I'm now going to do calculate. I'm going to choose the exponential regression, not the AB regression. AB exponential has B as the base. I've been told my base is E, so I'm going to use exponential regression and OK. And it tells me that the A value is 0.92 and the B equals 0.295 to 3 decimal places, 0.30 to 2 decimal places, 0.3 to 1 decimal place. So they're the values of A. Now you can see it's hugely dependent upon how accurate you read this scatter plot. Okay, that's section A for number 4. Question number 5. George and Renee are both starting exercise regimes that include going for a bike ride every second day. During week 1, they both ride 1 kilometre on each ride. George will then increase the distance he rides by 1.5 kilometre each week. Renee plans to increase the distance by multiplying by a factor of 1.5 each week. Okay, so I need to draw separate scatter plots. Okay, so I'll go back up here, edit, clear all, okie doke. Now this is for George. 1, 2, 3, 4, 5, 6, 7, 8. And George on week 1 rides 1. He then increases by 1.5 each week, so it's going to be 1 plus 1.5, which is 2.5. The next week he's going to have 2.5 plus 1.5, which is 4. Then of course the next week's going to be 5.5. Then we're going to have 7. Then he's going to have 8.5. He's going to have 10. He's going to have 11.5. He's increasing by 1 each time. And when I do a scatter plot, there's George's scatter plot. It's a straight line. It increases by 1.5 each week, therefore it has a gradient of 1.5. And in the first week it was 1.1. Sorry, it was 1 and 1. So I know from my work to do with straight lines, if I'm at 1 and 1, if I'm here at 1 and 1, and I have a gradient of 1.5, I need to go down 1.5 and across 1. I'm going to have a y-intercept of negative 0.5. So I think that George's rule is going to equal y equals 1.5x minus 0.5. Because this starts at 1 and 1, and that our y-intercept is when x equals 0. So if I'm going up by 1.5, I need to go down by 1.5 to get back to that point. So if I bring up my calculator again, and I go back up to my table, and I calculate a linear regression, I'm going to find that a equals 1.5, and that makes sense, that's my gradient. But the b equals negative 0.5, which is my y-intercept. Because if I go back to 0, then it's going to have to be 1.5 less than 1. So that part, draw a set of, well, I've drawn my scatter plot. I think it's linear, and I've come up with my rule. That's my rule there, and my calculator confirms it, gives me the same rule. Okay, what about Renee? I'm going to use list 3 for Renee. Renee also has 1 in week 1, but she increases by a magnitude or a factor, a multiplier of 1.5. So 1 times 1.5 will be week 2, and week 3 will be 1.5 times 1.5, and week 4 will be 2.25 times 1.5. So I'm multiplying by 1.5 each week. So 3.375 by 1.5 and 5. Okay, I'll copy and paste. Copy. Paste times 1.5. Okay, so I've gone through and completed Renee's list. Now Renee has a multiplier by 1.5, so I'd expect Renee's rule to be y equals some starting value times 1.5 to the power of x. Now my base has to be 1.5 because that's what I multiply each by. Now don't get fooled to think that a is going to be 1, because a is going to be this value back here that would have happened had I started at time 0, because the y-intercept is when x equals 0, and we started counting when x equals 1. So it's going to be something like 0.8 or 0.7 or 0.9 or 1. Now it's going to be less than 1, but when you multiply it by 1.5, it's actually going to equal. Now I could work it out, because I know that my multiplier here is x, and I know that at 1 this equals a times 1.5 to the power of 1, which means that a equals 1 divided by 1.5. 1.5 is 3 on 2, therefore 1 over 3 on 2 is 2 on 3. So a actually equals 2 on 3. So I'd expect my rule to be, for Renee, y equals 2/3 times 3 on 2 to the power of x. Now let's see if my calculator confirms that. What do I need to do with my calculator? I need to do a calculation. I wish to use AB exponential regression because my base is no longer E. I've got to work out what the base is. My list is, my y's are in list 3. Okay. And there I get A is 0.6666, which is 2/3, and B equals 1.5. And that's it. And of course it will then graph it for me. And it's scattered plot of George, and then there's my linear regression for Renee.